Unit 2, pages 27 to 33, Molecules, Elements, and Compounds. Molecules of elements. A molecule is more than one atom bonded together. The atoms in the molecule are chemically joined together. When all the atoms are the same number of protons, it is called an element. When the number of molecules bonded together is very large, we no longer call it a molecule. Instead, it is referred to as a solid or crystal. The subscript O3 means there are 3 atoms in the molecule. So here is H2, where you have 2 hydrogens, Be2, 2 beryllium, O3, which has 3 oxygens. And then this is lithium metal, which is going to have a series of lithiums placed in a structure. Compounds. When there is more than one type of atom in the molecule, it is called a compound. All water molecules have the formula H2O. The proportions of the atoms in the molecules are always the same. When atoms are grouped together in different ways, the chemical properties change. H2O2 is a different molecule from water with different chemical and physical properties. The properties of elements are different from those of the compound. Hydrogen and oxygen are colorless gases, while water is a liquid that acts as an excellent solvent for many materials. And recall that H2O2 is hydrogen peroxide. So here you have HF molecule, H2O, carbon monoxide, and H2CO or formaldehyde. Important distinction to make. Molecular compounds are elements and compounds made from only nonmetals are called molecular compounds because they exist as individual molecules. Nonmetals can be combined in a wide number of proportions to make different molecular compounds. Here's a chart with examples. Hydrogen and oxygen can form water or hydrogen peroxide. Nitrogen and oxygen can form NO2, N2O4, N2O5, and C and H, carbon and hydrogen, can make CH4, C2H4, C2H4, so they can have different proportions between the atoms. So it's always going to be 2 or more nonmetals which are found on this side of the periodic table. In contrast, ionic compounds are compounds made from a metal and nonmetal atoms or polyatomic ions and are ionic. The atoms in the compound are charged. The proportions of the atoms in the compound are fixed and are determined by the charge. The chemical formula represents the empirical formula because the actual molecule is a crystal that contains many formula units combined together. An example of an ionic compound is sodium combined with fluoride. Remember, this is a metal combined with a nonmetal, and that's going to be considered ionic. So ionic compounds form into what's called ionic crystals. Table salt, or NaCl, is made from sodium and chlorine atoms. The picture below shows an electron jumping from a sodium atom to a chlorine atom, creating charged ions. In a solid crystal of NaCl, the atoms are charged. The charges create attractive forces. These forces are the glue that holds the crystal together. Since the number of atoms bonded together is very large, it is referred to as a sodium chloride crystal. There is no individual sodium chloride molecule. The formula, NaCl, is the empirical formula, which indicates the simplest ratio of atoms. Here's the electron transferring from sodium to chlorine, which causes the sodium to become positive, chlorine to become negative, but there is no single molecule. They form a network called a crystal lattice, or you can just refer to it as a crystal. Notice the positive ion is surrounded by negative ions, and each negative ion is surrounded by positive ions. Empirical formulas and molecular formulas. Molecular formulas describe the actual number of atoms in a molecule, while an empirical formula describes the simplest whole number ratio of the atoms in a molecule. So here would be the actual formulas of these molecules, which is going to be the same as the molecular formula of those molecules. However, if you take the simplest ratio between 2 and 4, that's going to be 1 and 2, and that's the empirical formula. So here, this could be reduced to just 1 carbon, 1 hydrogen, therefore that's the empirical formula. This cannot be reduced, and therefore that is both the empirical and the molecular formula. We could reduce hydrogen peroxide because 2 and 2 is the same as 1 to 1 ratio, and then C8H18 could be reduced to C4H9, which is the empirical formula. Notice that the molecular formula is equal to N times the empirical formula, where N is some integer that multiplies the subscripts of the empirical formula. For example, C6H6 is equal to 6 times C and H, where the integer 6 multiplies the subscripts of the atoms in the empirical formula CH. Alright, notice this guy over here. Put a big star here. And these are some of the polyatomic ions you are required to memorize for this course. So I would put these on a separate sheet of paper or on some note cards and get started memorizing these. Polyatomic ions. Certain groups of atoms prefer to stay bonded together in a charged form. They are called polyatomic ions. Hg+ is the mercuride atomic ion, and Hg2 is the mercury 1 polyatomic ion. More than one atom is in the ion. Remember also that ionic compounds can be made from all nonmetal atoms by using polyatomic ions in the compound. So here, NH4 is ammonium, and together they all possess a positive 1 charge. This is a polyatomic ion. Whereas the chloride, because it's only a single element, is a monoatomic ion. You must memorize the names, formulas, and charges of the polyatomic ions in the table. These are the most common polyatomic ions we will use in Chem 1201. FYI, these are some additional polyatomic ions found on page 34 that I would also go ahead and commit to memory. Here's your note card for this section. A molecular compound is 2 or more nonmetals, while an ionic compound is a metal in a nonmetal. The molecular formula is the actual number of atoms in the molecule, while the empirical formula is the simplest whole number ratio of atoms in a molecule. The molecular formula is equal to an integer times the empirical formula, where n is an integer that multiplies to all the subscripts in the empirical formula. The polyatomic ion is 2 or more nonmetals with an overall charge, although in the case of mercury 1, you notice it's Hg2 plus 2, that's 2 metals that have an overall charge. But the key here is 2 or more have an overall charge. Page 33 and 34 have polyatomic ions that you need to memorize. These don't include the ions you should be able to determine off of the periodic table, which we'll review at a later time.